In previous videos, we already derived rules to find the derivatives of the sine and the cosine. So we know that if y equals the sine of x, then the derivative of the sine is the cosine of x. If y equals the cosine of x, then the derivative of the cosine is a negative sine of x. Now let's look at how we get the derivatives for the four other trigonometric functions. So let's start off with the tangent. So for this example, if y equals the tangent of x, let's find y prime. Alright, so to come up with the derivative for the tangent, it's not like finding the derivatives for these. These we actually had to use the definition of the derivative. The way we come up with the derivative of the tangent is we rewrite this so it's y equals, well, the tangent is the sine of x over the cosine of x. So we'll use our identity, that tangent, sine over cosine, and then notice that the sine over cosine is a quotient rule. So we can take the derivative of that. So y prime, okay, now remember the quotient rule, you have the bottom, the cosine of x, times the derivative of the top. Well, the derivative of the sine is the cosine of x, minus the top, which is the sine of x, times the derivative of the bottom, which is a negative sine of x, all over the bottom squared. Okay. So then this means that y prime is going to be, well, cosine times cosine is the cosine squared of x. Now we have a minus sine times a negative sine of x, so these two negatives become a plus sine squared of x all over the cosine squared of x. We have another identity that sine squared plus cosine squared equals 1, so this is just going to be 1 over the cosine squared of x. And 1 over cosine is secant, so that means y prime is going to be the secant squared of x. And that would be the derivative of tangent. Okay, let's do the same thing for cotangent. So if y equals the cotangent of x, we want to find y prime. Okay, so it's the same idea. We rewrite cotangent, so y is, well, if tangent sine over cosine, then cotangent must be the cosine of x over the sine of x. And so our derivative is going to be the bottom, sine of x times the derivative of the top, negative sine of x, minus the top, which is the cosine of x, times the derivative of the bottom, which is the cosine of x. And this is all over the sine of x squared. Okay, so if we simplify this, we get y prime, let's see, sine of x times a negative sine of x is a negative sine squared of x, minus the cosine squared of x all over the sine squared of x. Now this almost looks like sine squared plus cosine squared, so we could put in 1, but we do have the negative, so let's first factor out a negative. So we have a negative sine squared of x plus the cosine squared of x all over the sine squared of x. And so this equals a negative 1 over the sine squared of x. So So that means, I guess I'll put it over here, y prime, well, 1 over sine, that's what, cosecant? So it'd be a negative cosecant squared of x. Okay, so there's our second trig function. So far we have that the derivative of the tangent is the secant squared, the derivative of the cotangent is a negative cosecant squared. Alright, let's try the secant. If y equals the secant of x, we want to find y prime. Okay. So you're probably getting the idea of how we're doing this, because again we take our trig function and the first thing we do is rewrite it in terms of sine and cosine. So in this case we're going to have y equals 1 over the cosine of x. Now this is a quotient rule, it's just that we have the numerator has a function of 1. Now that does make it, in some ways, a little bit easier, because we have the bottom. Whoops. That should be just a y, sorry. So y prime is just going to be the bottom, which is the cosine of x times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom. Well, the derivative of the cosine is a negative sine of x all over the cosine of x squared. Okay, so we're going to end up with y prime equals 0 plus the sine of x all over the cosine squared of x, which is just the sine of x over the cosine squared of x. Okay, now, even though that technically is the derivative, it's not how you find it in books. And one reason we rewrite it is, even though this isn't a big rule, it is something that we do try to follow. And that is, we don't want to have trig functions in the denominator. So what we do is we're going to split this up. Okay, we're going to take this cosine and we're going to have 1 over the cosine of x, and we're going to multiply that by the sine of x over the cosine of x. And so finally we can get y prime to be, well, let's see here, 1 over cosine, that's the secant, and then sine over cosine is the tangent. So the derivative of the secant of x is the secant of x tangent of x. Alright, let's try one more. If y equals the cosecant of x, you want to find y prime. So that means the cosecant is 1 over the sine of x. So y prime is going to be the bottom, sine of x, times the derivative of the top, which is 0, minus the top, which is 1, times the derivative of the bottom, which is the cosine of x, all over the sine of x squared. Well, the sine of x times 0 is just 0. So this ends up being a negative cosine of x all over the sine squared of x. Alright, so then this is going to be, okay, so again, we tend to not want to have trig functions in the denominator, and so we're going to rewrite it, and for us to rewrite it, we're going to separate this. And so we have this negative, and then I'm going to factor out one of our sines, so we have 1 over the sine of x, and then we have the cosine of x over the sine of x. So then we end up with y prime, well, we get a negative 1 over sine is the cosecant of x. Cosine over sine is the tangent of x. Good. Alright, so we were able to find the derivatives of the other 4 trigonometric functions. For tangent, it's secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent, and the derivative of cosecant is a negative cosecant tangent. Okay, so now, of course, there's this idea of, well, do we memorize these, formulas, we could say. And in general, we do not memorize these. I never memorize these because I would have a hard time keeping track of all this. When I ever need the derivative of, say, cotangent, most of the time if I need this derivative, I just quickly, if I'm working on a problem, I just quickly go off to the side and do a quick derivation and figure out that it's a negative cosecant squared. Of course, over the course, we work with tangent enough that we might actually memorize that it's secant squared. However, for the most part, when we do these, we always rederive it because it's hard to remember them all, especially secant and cosecant. I can never remember those. So it's just kind of something to keep in mind that, you don't really memorize these, you kind of just rederive them every time you need them. However, but now that we've derived them, then we can do an example here. Let's look at this example. If y equals 3x to the 4th times the tangent of x, find y prime. All right, so here would be an example. And in this section, because we kind of are just sitting there looking at these, we could probably find the derivative quickly. Because y prime is going to be the first, 3x to the 4th. Now this is a product rule, so you got the first times the derivative of the second. And we already figured out that the derivative of the tangent is the secant squared. So this is the secant squared of x. Plus the second, which is the tangent of x, times the derivative of the first, which is 12x cubed. Right. Now, if this were, say, a couple months down the road and we just didn't do this and it wasn't fresh in our mind, and we had to find this derivative, or if it's on a test and you don't have any notes, well, the way that it might work is you would say, well, I have the first, 3x to the 4th times the derivative of tangent. And you'd think, oh, I don't remember tangent. So you'd go over here and quickly rederive tangent, and then you'd figure out, oh, it was secant squared, plus the second, tangent of x times the derivative of the first. And so that's how it normally works. You kind of have to do a little bit of a derivation over here. Well, let's go ahead and rewrite this. This would be y prime equals 3x to the 4th times the secant squared of x plus 12x cubed times the tangent of x. And there is our derivative.